Let us move to the next topic of linear programming problem, which is formation of LPP. Without forming the linear programming problem, we can't solve the linear programming problem. To understand the formation of LPP, we discuss the some basic term which we need to know more about the formation. First is decision variable. It is used to represent the level of achievement of particular course of action. Suppose for example, suppose we want to produce two different product, say P1 and P2. Then the first question is that how many number of P1 and P2 we will produce, and this represent the decision variable. Next is objective function coefficient. The objective function coefficient is actually a constant which represent the profit per unit or cost per unit carrying out the given activity. The objective function is expressing the total profit or total cost, therefore it may be maximum or minimum. Our objective function is maximize or minimize. Next concept is technological coefficient. It is amount of resources required for the activity. Next, resources available. The available resources means amount of resource available during the planning period to complete our task. Suppose we have to produce any product and we require to produce product P1 are 20 hours and product P2 for 30 hours, then it is a resources. Now the set of constraint, the kind of restriction on the total amount of particular resources required to carry out the activity at a various level. This is a set of constraint means restriction. We have given the restriction when we will perform the operation or we will form the given LPP. And last one is non-negative constraint. Each and every decision variable in LPP model is non-negative constant because we have to find the number of product, therefore it never be negative. Let us move to the examples on formation of LPP. First example number 1. A farm produce 3 products on a 3 different machine. We have given that it produces the 3 products on the 3 different machine and time required to manufacture 1 unit of each of 3 products, and daily capacity of these 3 machines are given in the following table. See, the 3 machines say M1, M2, M1, M2 and M3. Product 1, 2 and 3. Machine M1 prepared for product 1 and time per unit means to prepare a product 1, machine M1 required 2 minutes. For product 2 it required 3 minutes, and for product 3 it required 2 minutes, and machine M1 having the daily capacity is only 440 minutes. Similarly, machine M2 require 4 minutes for product 1. It does not prepare product 2, and product 3 minutes, and daily capacity of machine M2 is 470 minutes per day. Similarly, machine M3 is product 1 required 2 minutes, product 2 require 5 minutes, and it does not prepare product 3 and its daily capacity is 430 unit. It is required to determine what we have to find. It is required to determine the daily number of units to be manufactured, and for each product the profit per unit production 1, 2 and 3 are rupees 4, 3 and 6 respectively. Means what? Per unit profit for product 1 is rupees 4, for product 2 it is rupees 3, and for product 6 it is, for product 3 it is 6, and it is assumed that all the amount produced are consumed in the market. It is also necessary because if the amount you produce, if it will not consume in the market, we will not get the profit. Therefore it is also assumed that all the amount produced are consumed in the market. We have to find out the daily number of unit to be manufactured for each product. Suppose we have the product 1. Product 1, suppose we prepare x1 product be the number of unit to be manufactured for product 1. X2 be the number of units to be manufactured for product 2, and x3 be the number of unit to be manufactured for product 3. Now see the given condition. Product 1 require 2 minutes. Machine M1 require 2 minutes for product 1. Machine M2 require 4 minutes, and machine M3 require 2 minutes for product 1. But machine M1 having the daily capacity is 440 minutes, and machine M2 is 470, machine M3 is 430. Our aim is first to write down the objective. We have to find the profit. Therefore our objective function is must be of maximization type. Product M1 having profit of rupees 4 per unit, product 2 3 rupees, and product 6 rupees. Therefore our objective function is maximize z equal to 4x1 plus 3x2 plus 6x3. Objective function is maximize the profit, and per unit cost is, per unit profit of each product is rupees 4, 3 and 6 respectively. Therefore this is our objective function. Now we will find our constraints according to this one. Product 1 required 2 minutes. Therefore the constraints are 2x1 plus 3x2 plus 2x3 less than or equal to 440, because the daily capacity of the machine is 440 minutes, and hence our objective function is 2x1 plus 3x2 plus 2x3 less than or equal to 440. Similarly the other objective function is this one, 2x1 plus 3x2 plus 3x3 less than or equal to 440, because 2 3 2, it is 2, less than or equal to 440. Next 4 and 3, x1 variable and x3 variable, therefore it becomes 4x1 plus 3x3, and machine daily capacity is 470, therefore it is 4x1 plus 3x3 less than or equal to 470. Similarly, the last constraint is 2x1 plus 5x2 less than or equal to 430. 2x1 plus 5x2 less than or equal to 430. All the variables are non-negative. This is the formation of given LPP. And we know that how to convert the given LPP in the standard form. We have the objective function is 4x1 plus 3x2 plus 6x3. The constant is of less than or equal to type. Therefore, add a new variable, say x4, in the first constant. It becomes constant number 1. Add new variable x5. It is the second constant, and third is also less than or equal to. Therefore, add x6. It is a third constant. All the variable which we have used in the given LPP to convert in the standard form are non-negative. x1 to x6 are non-negative. Similarly, the canonical form inequalities are in the standard form. Canonical form inequality are in a less than or equal to type. Therefore, no need to add a new variable. Next example number 2. This is our canonical form, first constant, second constant and third constant. No need to add any variable or subtract any another variable. Therefore, it is in canonical form. Objective function maximize, it is in maximization form. Constant less than or equal to less than or. All variables are non-negative. x1, x2, x3 are given in the non-negative form. Let us move to the next example.